Hello, everyone. My name is Paul Hazelton, and today I'm going to tell you about Alan Turing, who is widely known as the father of computing. So, brief outline of where we're headed. First of all, this is a picture of Alan Turing when he was just 16 years old. First, we're going to explain who is Alan Turing. Then we're going to go through what he did in his life and all the amazing accomplishments he has. Later, I'm going to explain what a Turing machine is, which is something that he came up with that helped improve stuff and change the world forever. Then I'm going to tell you about the halting problem, which is the main focus of my paper. And we're going to go through a simplified proof of the halting problem. So first of all, who is he? Mathematician, computer scientist, and a hero, and a victim of prejudice. He was born in London in 1912, and he massively influenced computability theory, basically started computability theory, and he built the bomb computer that cracked the Enigma code. The Enigma was this machine that encrypted messages for the Nazis, and he cracked it with this machine he built so that the British could have intel. So what was his groundbreaking work in computability theory? There's this famous German mathematician, David Hilbert, who you may have heard of. He posed the decision problem. I think it's pronounced the Entscheidungs problem in 1928. And a few years later, Alan Turing, an English mathematician, proved this to be unsolvable using his idea of a Turing machine in 1936. This was an English mathematician building on top of a paper by a German mathematician. And then just 3 years later, war between Germany and Britain. Britain declares war with Germany for World War II, just 3 years after this paper. Having information about the enemy is extremely valuable. This has been shown time and again through war. The Nazis used this machine called the Enigma to encrypt their messages so they could send to each other, the other Nazis during the war. As you can see here, there's this switchboard here with these letters on it and these 3 dials here with numbers on it. Every day, they would change the setting of these 3 dials and rearrange the switchboard. And the switchboard would route letters to different letters, and these 3 dials would change the settings on how the machine encrypts the messages. So every day, the messages were encrypted, but also every day they were encrypted in a different way. So the same message encrypted on Monday would look completely different to Monday's encrypted message on Tuesday, because they would change these dials. And Alan Turing was hired to help decrypt these encrypted messages because they were looking for geniuses to work on this. The other decryptors that were working on the same team, they were failing because they had to start over every day. Any progress that they made, like on one particular day, and sometimes they would figure it out on a day. They would decode it once in a while, but then the next day they didn't have any progress. Like, it didn't matter how far they got the day before. They would have to start over every day. And Alan Turing didn't like this, so he had a creative idea to do this differently. He designed this machine called the bomb to decrypt the messages. The machine would do the hard work for him. It would do all these kinds of statistical analysis, and the machine would do it. And this machine actually worked. It would take sometimes 2 to 4 hours. Sometimes it would take longer. Sometimes it wouldn't work. But most of the time, pretty quickly, the British suddenly had all this intel about the Nazis and what they were doing in their plans. And like, basically, Alan Turing saved, like, some people estimate 14 million lives. He was a hero. He, like, saved millions of people. And also accidentally pretty much started the computer science field and then changed the world, because we use computers absolutely everywhere. And so sadly, after years of service to his country, he was criminally charged for loving someone in 1952. He had the audacity to be in love with another man, and he was given the choice between prison and chemical castration. Turing chose the latter. And just 2 years later, he took his own life. The chemicals that he was forced to take changed his physiology, changed the hormones in his brain, and most people believe that this was what drove him to suicide. However, it is somewhat disputed whether or not it was actually suicide. It is believed that the half-eaten apple at his desk was laced with cyanide by himself. Some people believe that he was working with chemicals anyway after his work in World War II, and some people believe that it was a mistake. But most people believe that that is just a comforting story to make his mother feel better, and that it was in fact suicide. Aside from that sad story, we're going to talk about what a Turing machine is, this amazing thing he did in his life. So it's a theoretical device that is basically a little computer that can read an infinitely long tape. It can read from it and write to it. Now, the infinitely long tape part, if you ignore that, then right now you're looking at a Turing machine. This is a simple Turing machine, a simple like diagram. So there's a set of states and a set of configurations and a set of behaviors. And this table here is a convenient layout so to hopefully more easily understand it. So for example, suppose we start at state A, and the machine at state A does not care about the input. It will print a 0 on the tape, move 1 square to the right, and then change its state to B. And then in state B, it doesn't care about the input. It will print a 1, move to the right, and change the state back to A. This simple machine will just print 1s and 0s on the tape forever. And it will go on forever, and it will never halt. It will always continue. So this is the way that Turing thought about machines, but we can consider an abstracted view so we can go through the proof easier. So here's an abstracted view of Turing machine, very simple. We don't care what happens inside this box. Whatever it's intended to do, it does. It takes input on the left, and its output is on the right. My mistake. So, what is the halting problem? David Hilbert proposed the decision problem, and it is this. Can an algorithm exist that can decide if a mathematical statement is provable? That would be pretty great if we could come up with a statement and like maybe it's impossible to prove. So you run it through a computer and the computer tells you whether or not it'll work. Alan Turing basically rephrased this question and said, can there exist a Turing machine, H, such that when provided another Turing machine, P, and P's input data, little p, as input for H, H will then decide if P will halt on a given input P. So basically, H looks at a program and says, hey, that's going to go into an infinite loop. Or it says, that's going to halt, and it's going to give you the answer. Whether the answer is right or not, who knows? But it's annoying if you want to run your machine and like maybe it'll come up with an answer tomorrow. Maybe it'll take a year. Maybe it will never finish. So it would be cool if you had this machine that could figure out if it'll loop forever or halt. And Alan Turing proved that this machine cannot exist by contradiction. So assume H is this Turing machine and it exists and it can do this problem. It takes in another machine and an input and it decides if it will halt or not and prints out true or false. So now we build a new machine, H prime. H prime has H inside it. It takes a machine as input. It will give that machine to both inputs for H. And then H prime will negate the output of H. So if H says true, P will halt. Then H prime will not halt and it will loop forever. If H says false, P will not halt. Then H prime will halt. So it will flip the output. And now is when the confusing magic happens. We can feed H prime as an input into itself. So notice that H is predicting the results of this very experiment that we are conducting. We're feeding H prime into itself. And what's going to happen? H better be able to figure that out because we assume that it can. So there are two cases. H prime gets fed into both these inputs, and then H says, you know what? I think this machine is going to halt. So it says true. And then H prime doesn't halt. And that is exactly contradicts with H. So H was wrong. The only other case is H says, actually, I think H prime is going to halt. Or I'm sorry, H prime will not halt. And then H prime will take that output, negate it, and halt. And again, H was wrong. So in all cases, H gives an incorrect result. And this is a contradiction. So H cannot exist. H cannot solve this problem always. Like maybe we can get one that can sometimes work, but it cannot solve it for any generic program. It cannot determine if it will halt or not. And that's it. That proves it. So there are many consequences of this fantastic proof. For one, David Hilbert's question, can an algorithm exist that can decide if a mathematical statement is provable? No, because that is equivalent to the halting problem, and that is unsolvable. Computers are limited. Can your computer do everything? Can it solve any problem? Absolutely not. That's impossible, because there are some problems that for sure are impossible to solve. Some algorithms cannot exist. No matter how smart you are, you will not ever be able to figure it out. Some problems will not ever have a definite solution. So, long after Alan Turing's death, people remember him. He basically created computer science, and the atrocity that the government committed against him was acknowledged, and they apologized for it. They pardoned Alan Turing, and many years later, very recently, in 2017, they enacted the Policing and Crime Act, which is often called the Turing's Law. And it pardoned thousands of men who were convicted for gross indecency, men who were doing things that were illegal, but they did nothing wrong. They were simply loving people. And they have now been pardoned. Thousands of people have been pardoned. And just to further remember him and honor him, it is very likely that he will be on the face of this 50-pound note here. This is the design they came up with. And by the end of 2021, this will probably be the 50-pound note. So Alan Turing, fantastic mathematician, computer scientist, and he was a hero. Thank you for watching my presentation. I hope if you have any questions, you can put them on the Blackboard discussion area. I'd love to hear them. Have a great day.